Hey guys, let's look at this question 453. Minimum moves to equal array elements. Given a non-empty integer array of size n, find the minimum numbers of moves required to make all array elements equal, where a move is incrementing n minus 1 elements by 1. What does it mean? 1, 2, 3. 3. Only 3 moves are needed. 1, 2, 3. 2, 3, 3. 3, 4, 3. 4, 4, 4. Find the minimum numbers of moves required to make all array equal, where a move is increasing n minus 1 elements by 1. So this is the first time I made this question. So 1, 2, 3, we need to left out. So let's say the total sum is 6. We now need to add 2 to them, right? So at this one, this is 2, 3, 2, 3. And add 2. This is 3, 4, 3. And then add 2. So I think this should be done. So first they must be the same, and the final result is the same, so it must be divided by 3, right? The sum. So currently is 6. The next one is 9. And next one is 12. If it's 1, 1, 3, we can add it 2 times to make it 3, 3, 3. I think this one is, how can I solve this problem? Let's say if you want to make it all 3s, it can't, because I have to divide this 3 must be turned into 6. I cannot do that. Now take a look up. Let's try something else, like 2, 8, 10. What the strategy is? The strategy is, of course, we add. Let's look at this. Is 18. Next one is 21. Cannot add them all to 10, right? 21, 7 is not okay. So minimum is 30. Cannot add to that. So plus, or just a straight up. Oh yeah. So the first one is 2 must be 10. So at least it must be 10, 8, 10. And then he must be 10. Oh no, 10, 16, 10. Okay, and then it must be at least 16. So 6. 6, 6. Uh-huh. So we just I think the main moves is just can be done in a recursion. Like first, we find the max and the min, and do it then recursion. That min equals nums 1. That max equals nums 0, 4. That's the edge case. If non-empty, okay. For let I equals 0, I is smaller than nums, the length, I plus plus. If nums I is smaller than min, nums I equal min equals nums I. If nums I is bigger than max, max equals, so find the min max. Okay. If we cannot find the min max, then so everything is the same to min max, right? So is let is all equals true. So this one is false. False. If equal, okay, we do recursion. Const transform walk array extra steps that are is all equal, then just return steps. If not, return steps plus walk. If not, we will set all to the max. Else update for let I equals 0. No, we can just update here. Update here. You don't know what max is. Okay. 4. We don't need to walk. Use recursion. We can just use the 4 iteration here. So we say let is all equals true. Was false. Okay. So while is not equal, let steps equals 0. Is what equal this true, but it should be false. Okay, now min is this one, all equal true. Okay, we find the min max. Okay, steps plus equals max minus min. Max index. So 0, 0. Nums, not array. Nums index min index equals I, is bigger than nums max index equals I. Okay, so steps should be nums max index minus nums min index. This is the steps. And for let I equals 0, I smaller than nums length, I plus plus. If I is not max index, nums I equal plus this one. Steps, constant steps plus step. This one is step, and then we'll loop 3 again, and we finally return steps. Will this work? It seems working. But time limit exceeded. It works, but it's not fast. It takes us 5 seconds. Any improvements? Any improvement is that okay with plus 6. Plus 6, so it is gonna be 8 should be it's not fast. Let's say I will have 8 to 8, 10. So according to our algorithms, we must add it to 10, 16, 10, right? And then we should be 16, 16, 16. I mean, if there are 3 numbers, this could be directly calculated. Let's say is there 5? Okay, it's the same. 16, 13, 10. And then we update these two to 16. Should be 16, 16, 19, 16. Right? And then we update these two 19, 19, 19, 19. So every time we can, there are only so this number actually could be calculated, right? 13 is get from 13 is get from 10 minus 2. And 8 minus 2. And 5 minus 2. So actually, it is the sum of all numbers, all the differences of all numbers to the minimum. I don't know the why, but why? Because every time we are approaching, like 2 to 10, okay, now, but 8 is changed, so we not change to 10. Wow, it's pretty simple. We can directly calculate it. We find the smallest first. Okay, let's just rewrite the code. Let main equals num0 for let I equals 0, I smaller than num. Let's use some cool methods. We use reduce. Yeah, reduce main item return max min. Positive infinity. This is main. So, and return nums reduce some item. Return some plus item minus min 0. Max is not defined. Oh, max, sorry. Wow, it's still not that fast. How can we be faster? If we can do 8 to 10, so get this one, so it'll be 6 and then 5. And we will card to 8, 8. Smaller than it, so then plus 3. Eight, 5, 10. So the first is 8, 10, 16, 13, 10, 16, 16, 19, 16, 19. So actually this is 8, and this is 6, and this is 3. So the minimum, the difference between the minimum number to all the other numbers, the sum of them. If there is a better method, is so we can say 6, and then 3, 3. This is 6. This is 8. Here's a 6. Okay, 3. We can do 8, 8, 8, 10, and then we all go to 10. This is the minimum, so we have to eight, right? It's 5, should be 3. But we don't know the minimum. So if it's 5, 8 to 10, minimum. So we got this is 3, and then we got 2. So we got a mistake that we got 8, 8, 2. We need to plus 10, plus 10, plus 8, 6. Wow. First is saying we need to find the minimum. Is it reduced somewhere? I don't think so. Let's say 4. Let min equals 0. Infinity. Let I equals 0. Why it is not that fast? First one, I will find the minimum. Maybe I can try to work with one round, right? Maybe. Let's try. If it's 2, 8, 5, 10, let's say, okay, it's nothing. Okay, we say there's 2, because, okay, we got 8, so we need to plus 6. So we plus to 6, 8, 8, 5, 10. We got 5. We got no 5, it's just 11 and 16. And now 11, 3, plus 3. So 11, 11, 11, 3, and 6, 19. And then we got 19, and then 8. Ah, we can do it in one round. We don't need to get the minimum. Yeah, we don't get the minimum. We just calculate the steps for, okay, for let I let current equals nums 0. For let num of nums nums empty. Yeah, it's not empty. I can ignore that. Okay. The lumps of nums steps plus equals num minus current. Right? Steps 0. So the first num is steps plus 0, 0. Current 0. So 0. So next number is 8. 8 will be plus 1, 7. Okay, for each number, what we need is to compare to the current. Okay, if you're not, so add it to them. So current should be, but the current is also changed. Like if you add 6, steps is becomes 6, and you go to the next one is with it's 1, so it should be 7. 7 minus current is 8. S is 1. But this changed the other thing. If it is smaller than it, then we should add them first, right? If it is smaller than it, then we should it first to be Oh, I'm stuck here. Alright. For example, 1, 2, 3, we got, first is okay, so 2, so it is 2, 2. Step is 1. and then go 3, 3. Current is oh, I didn't update current, so current equals max plus steps. This is one run. Mistake. 1, 2, 3, 2, 2, 3, 3, 3, 3. Two to 4. 2 to I don't know. I cannot do. Let's look at the solution. Yeah. Complexity. Better proof to force. Sorting. Sort. So in our previous one, we the first one is n, right? Find the minimum, and then sum. So the on. The project is based on the idea that adding 1 to all consecutive 1 is equivalent to decrement 1 from single event. Since we are interested in the relative levels of the elements, we need to be equalized. Thus, the problem is simplified to find the number of decrement operations required to equalize all the elements of a given array. For finding this, it is obvious that we reduce all the elements to an array of minimum element. But in order to find the solution, we need to accurately decrement the elements. We can find the number of moves required. Mean moves mean. Right? Moves plus main equals math main. Return moves me. I also have ON, but it's not fast. So there's a DP solution. We can break the problem of array into solving arrays of smaller sizes, assuming the elements up to index have been equalized. We can simply consider the x and add the difference between total number of But when we try to proceed with this step, as per valid rule, the elements following AI will also be incremented. But in previous approach, we need to increment all such. Instead, we'll add the number of moves done so far. The current element AI are updated to add moves. Adding 1 to all elements except 1 is equivalent to decrementing 1 from a single element. Since we are all interested in the relative levels of the elements which need to be equalized, thus the problem is simplified. Find the number of decrement operations required to equalize all the elements in a given array. To find this, it's obvious that we'll reduce all decrements to array minimum, but in order to find the solution, we did not actually decrement the elements. We can find the number of moves equivalent as moves to where n is the length of the array. Move 0, min equals max. Integer, okay, for each number, moves equals nums. Min and min and it's the same, right? Oh, maybe this will be faster. Haha. I see what is going on. I see what is going on. I see. Yeah. For each number of rows, so let sum equals 0. Sum equals 0. Sum plus num. Return sum minus min times nums dot length. Unexpected token. Where? Mm-hmm. What is this? Unexpected token. Where has this token? Ah, it's the command. XOR. Oh, this is oh, it is faster without. Ah, cool. I see. So that's it for this question. See you next time.